Greetings. In my last video, I talked about the sender side of my end-to-end architecture, which was essentially a Raspberry Pi reading in data from a gyroscope sensor, based on that reading determining programmatically whether to send an OK or an error, and then transmitting that system health data using an XBee device through the Zigbee protocol. In essence, transferring that data through a mesh network using peer-to-peer communication, reaching an XBee that was connected to a base station PC, listening and receiving that data being transmitted. And so, in this video, I'm going to dive deep into the Python code for the base station PC, which you see on the right here. At a high level, the base station PC is not only receiving that data being transmitted by the microcontroller about its health, but it's also processing that data using Python 3 and then storing that processed data to the cloud into a structured database. So as I show you my code, you will see how that works. So I want to start out by talking about the program structure for the receiver side. Very similar to the sender side, it is one main Python executable that is supported by two other files, namely the config file called config.json, a configuration file, and a helperfunctions.py, which contains all the helper functions that I used in the main file. And so this RecieveData.py file gets executed when its name is called. And when its name is called, it starts by executing the method main. And before it starts executing the method main, it imports the libraries and imports the respective functions from the helperfunctions.py file. And these are important functions, and I'll get to them later in this video. So when main begins execution, it prints this out, like console logging. And after it does that, it loads in all the configurations to initialize the XBee to which the base station is connected to. In essence, the receiver XBee, constituting the receiver side. And so, as you see in this configuration file, I have the XBee data, specifically the port and the baud rate. And so this JSON file gets read, and this device, specifically an XBee device, gets initialized. Once initialized, it enters a try-catch block, where if the device does not open, then it closes and it exits. Otherwise, it opens the device and then gets into execution of this callback function. So before I jump into this callback function, which is inside of the helper function, how this callback function works is after you use this add data received callback, you essentially print this out and then wait for the next input. And so you are in this, you're constantly in this iteration. Essentially, you're polling. And as input comes in, you're continuing to poll for that data and then waiting until more data comes in. So now I want to pivot to the helperfunctions.py file to specifically talk about this function, which is the most important one, and then this function here, which pretty much is a getter that gets data from my config file. So first, before jumping into the specific functions, I want to talk about the setup. The setup for sending the data from the base station PC through the cloud into a database, namely a spreadsheet, a Google spreadsheet. And since it's a Google product, I'm importing this library, and I talk about these libraries in a subsequent section, a later section in the final documentation website. But I also have a requirements.txt file here for your convenience, where you can see the exact versions and what specific libraries I used to achieve the functionality as demonstrated in this architecture. So jumping back to my helperfunctions.py, I initialized the OAuth client required for security authentication when making an API call to write and read data from the spreadsheet. I'll talk about the SNS piece a little bit later when I address the error notification capabilities of this application. But jumping into the get data, the getters in essence. So these getters would, so I have about 3 getters, one to get XBee data, the other to get the ambulance ID data, and the other to get the notification data. So what that means, at least at this point, is in my configuration file, I have 3 JSON entries. One for XP data that contains the port and the baud rate. The next for the ambulance data that's a key value pair that maps a MAC address, i.e., a burn-in address to a ambulance ID that I set up um, for two ambulances, and then some notification data, which I'll touch upon for SNS. And note here that this purposely blocked for security purposes, um, just to make sure the information here doesn't leak onto the web. And so now that you've seen this configuration file, essentially the helper functions, these three, they're just getters. They just fetch the data from that configuration file. And so the main meat and bones of this RecieveData.py is this callback function that continues to get callback and stays in a state of polling for data that gets sent from um, any one of the XP devices transmitting, well, connected to a microcontroller transmitting its health data. And for this project, I was only able to work with one microcontroller device. I can support multiple, but for the purposes of this demonstration and for this deep dive, I was only able to do one. So, um, coming back to my callback function, um, I call it from my RecieveData.py, right, right here. And what I do is I actually read in the message that gets sent by the sender XB. And at this time, once I receive the data, my first step is to get the data, convert it to string, and attach a timestamp as here. So here's the timestamp, here's the message converted being to string, and then I also store the sender XB's MAC address in this variable here. I do some console level logging to show the output on my screen. And once that's done, I open the config file to then check if the sender XB is actually a valid XB on the network. Meaning, does the XB's MAC address match what I have in my config file? And as such, does it map to what ambulance ID does it map to? And as you can see, I was preparing or designing for scale, but I was unable to due to financial constraints and others. But yeah, the idea would be based on whichever microcontroller transmits its data through the base station. I can check using this configuration file what specific XP that is and what ambulance ID it maps to. So um, once I validate the message once I validate the XB's MAC coming in, I then assign a ambulance ID. So I know what ambulance ID, what XB microcontroller I'm dealing with. I'm going to get back to this section in a little bit because this is attached to the error notification. But assuming in a regular workflow where there is no where an error has not been encountered, meaning a sender has not sent an error message, then what would happen is I would use my Google OAuth client to open up a spreadsheet, which is my database, fetch a specific table or a worksheet in this case from that database or that spreadsheet, and then retrieve the last written row. So I don't overwrite data, and my data consistently increments, uh, right? And so what I do then is after retrieving that row, based on that row, I write to the next row that's available. And so I update my worksheet with the ambulance ID, the message, and the time. To see a better demonstration of this code, I recommend going through my technical demonstration video, specifically the final release, and it would give you a very clear picture of how this works in the front end. In the back end, once I do write that code, once I do update the spreadsheet, I then update my last written row and update that into a cell, which I use to retrieve what was the last written row. And so that pretty much covers a workflow in which there is no error encountered. So to reiterate, once my main function is called, it enters a callback state, and in a callback state, it's pretty much polling. And once it's done polling, once a message comes in from a sender XB, it then attaches a timestamp, retrieves a message, and checks the configuration file to determine and validate what ambulance ID it is. Now, for the workflow where an error is encountered, I actually have implemented push notification feature where I use Amazon SNS. And again here, I have the security tokens and IDs blocked out for security purposes. However, I use my config file to pretty much load in whichever base station personnel is on the shift. And again, using the power of the configuration file, you can change these changes that are made in the configuration file um, um, occur in runtime, meaning you don't have to stop the program running on the base station to then enter the email or the cell of the base station personnel currently on shift at that time. You can simply edit the file while the program is executing, and the changes to reflect automatically as the program is executing. What that means is if an error is encountered, I read in data from my config file, fetch the email key like the value, and course, and then also the cell value using the helper function that I showed before, the getters, and then I create a SMS subscription. So I push a, I push a, I push to a topic. I could create a SNS like topic with respect to the cell phone that I had. Then I create an email subscription, an SMS subscription, then an email subscription, and then I publish to the topic for the email, which is this, right? Um, and I send to the topic the message that I received, which would be an error in this case, the time at which this message received, and what ambulance it was received from. And so what that looks like for my email that I have, right? For my email, it sends an email with subject this, and the message this. And again, I would ask that you would refer to my technical demonstration videos to see this in action. And to my cell phone, it would simply send a push notification without requiring a push to the topic, where it would just enter the cell phone number and it would just send this message. And so, given that there was an error encountered, it still executes this part of the code where it still writes the error entry into the spreadsheet. So all data is logged. And as such, that pretty much completes the workflow of the receiver where data is received on the base station PC. It is processed using Python 3, whereby timestamp is attached, the ambulance ID is retrieved, and then it is written to the cloud using Google Cloud APIs into a spreadsheet. And that, in conclusion, covers the receiver side of this end-to-end architecture. Thank you for your time.